Okay, I believe this is where we left off with yesterday in starting this new chapter dealing with organic compounds. And I think it is actually chapter 23. I think I have that wrote on the sideboard where all your lesson plans are located. And I think I remember leaving off here talking about hydrocarbons. So the only thing that we really didn't get to, we just briefly, we showed you some of these short chains. When we're talking about branched organic chains, that means those are some of those compounds that we'll refer to as isomers. We'll get into those today. And then we briefly showed you what a ring structure was, okay? And we'll get more into that later on in this presentation, okay? So when we're talking about all these hydrocarbons that we're referring to, we mentioned that last chapter, okay, dealing with balancing these chemical reactions. When you have a hydrocarbon, just meaning that of a compound, just hydrogen and carbon within it that combining with oxygen, okay, goes through the process of combustion, okay? And in this case, these hydrocarbons can form a single, double, and triple bonds, and we'll get into that at a later time. We briefly mentioned what a triple bond might be with a gas that might be utilized in the shop, and that is, of course, acetylene. And one of you students had mentioned that yesterday. Okay, so again, that we'll make reference to that later in this presentation. All right. So I might be wrong. This might be the first time that you've had to do maybe lecture notes from the basement here. It's one of the aspects that we had set up a couple years ago when we went to remote learning. Hopefully, maybe that helps. And I forgot I got a light down here too. And maybe that will hopefully clear that up a little better so you can actually see that. Okay, so moving forward then, okay? Just like we stated earlier, a compound made of only carbon and hydrogen, okay? And we talked about this yesterday. The simplest hydrocarbon, usually we refer to it as natural gas, but of course the scientific name then is that of methane. And you would use that to possibly heat your home should your water heater be a gas type. Some of them are electric, some of them are, of course, gas water heaters. And we illustrated this briefly. There's two ways to illustrate methane, okay? A chemical formula or molecular formula would mean you're just writing one carbon and four hydrogens, okay? That's one way. Then the structural formula is just that. It's illustrating what the structure is. You have one carbon in the middle with four hydrogens branching outwards from that central carbon. Okay. All right, moving forward. And at any time, you can always go back to the science channel and try to refer, okay, this is what I missed, this is what was said in class. Because one of the things I know sitting there in class, it's not the same, but this is the best that we can do in this situation. Okay. We also talked about propane. Why might you use that for heat? Well, that's a 3-carbon compound that you would probably utilize for your gas grill. And I believe some houses are actually equipped, if you have natural gas for your water heater, you can actually, a lot of houses are built now that actually have a natural gas line that will go to possibly your front or back deck. And what that would mean is you can actually just hook your grill up to that rather than having to go fill that propane tank up every time it goes empty. I know sometimes that gets to be a hassle, but one of the aspects I maybe found out the hard way, you just can't switch the what do I want to say, hook the grill up to that gas line and expect it to work. You have to change a lot of the internal components that come with that grill, just because when we look at propane, that being just a heavier gas because it's got 3 carbons in it as opposed to just 1 with natural gas. That's why I believe the burners are different, and probably the internal lines that supply the gas inside the grill would have to change too. So it's just not as simple as I thought it would be. I said, nah, I'll just go ahead and keep filling the propane tank up. Okay. Okay. So I believe I want to get through 2, 3 more slides perhaps. Okay. And we wrote this up on the board yesterday. Okay. When we're talking about single bonds, these are all alkanes because they have the same suffix. So we go from 1 to 10, and perhaps you have this wrote down somewhere in a notebook. We said spread them out. We had 5 in one column and 5 in the other. And it goes methane, ethane, propane, butane. And as we said yesterday, once you get up to number 5, pentane, all of these start to move on to the geometric shape of that alkane. Okay? So when we talk about structural isomers, okay, we illustrated this yesterday. Butane is a straight chain of 4 carbons, but you can have one of those that actually branches off of there, and then that is an isomer or a branched chain of an organic compound. Let's see, I always try to be conscious and aware of. I see we're up to a little over 7 minutes, but we'll go ahead and do some examples up on the board here in just a couple of moments. Okay, so I believe I want to do this slide, then the next one, and then we'll wait for multiple bonds upon our return on Tuesday. And there again, I believe a schedule change has taken place. You have a track meet that was added to the schedule in going to Centerville, and one class had told me that you leave it. Well, it doesn't matter because your class begins at time 11 o'clock anyway. It was supposed to be a 10 o'clock departure time, but now I think it's actually 9 o'clock, which again really doesn't affect your class because you're going to be gone anyway. So for a lot of you students that are going to be gone, this is a good reminder of this is your responsibility to keep current with this content, and this allows you to do that. Okay, so if I'm not mistaken, this will be the last slide that we do for today. Because again, if we moved any further, they'd be starting to talk about multiple bonds, and I think we could just as well as wait until Monday, or not, excuse me, not Monday, Tuesday, upon when I return. So when we're talking about structural isomers, that Sigma Aldrich book that is probably on that little file cabinet right in front of the video player. As you can see, it says thousands of isomers exist upon these hydrocarbons. And the print in that book is, of course, really small, and I just opened up a page that was on like 2,600. So those are just all of the different types of organic compounds that you could order. And when we think about all the different types of organic compounds that exist in nature, you can just see that there's not just thousands, but millions of, well, I don't know if I want to say millions, but tens of thousands of different types of organic compounds that would exist, because that includes sugars, of course, which are carbohydrates, proteins. The seniors, they're learning lipids right now. You might have seen some of those really long chemical formulas that were up on the board. Those are what we call carboxylic acids that possibly result in different types of esters, which make fatty acids, okay? Because this content will slowly build upon one another. You're going to learn some of the basics with organic chemistry this year. Then in 2 years, you also will learn a little more organic chemistry as juniors, and then as seniors, then that's all that you spend time on is organic and biochemistry. So we'll go over some of the examples that we had done yesterday. Okay. Okay, so remember what happens is we said, what pattern do you see arising from this? And okay, there's your methane or natural gas. Here you have a molecular formula, okay? Shows you the elements and the compounds that you have. This is a structural formula that actually just shows you what the structure actually is. So then in your handout that you were working on, I gotta make sure my batteries don't, I'm down to about 2 bars, so that's why I keep looking at that. This is one of the compounds that you saw in our handout. When we're looking at this, it's 4 carbons long, so we would refer to that as butane, okay? Because the prefix is 4, so that's where this comes from. Everything is single bonded or saturated, so that's where this comes from. It refers to your organic family. And as you proceed further into what organic chemistry is, a lot of these names will change, okay, to possibly something like, this is just an example, okay? Notice that the names are fairly similar, but with this type of suffix, when something ends in OL, well then that just means that it's an alcohol, and that means there's an OH group on there somewhere, okay? And if you remember from yesterday, if there's nothing written after these dashes, okay, that means those are hydrogen atoms. So then that's what we see here. We have an oxygen atom here and a hydrogen atom. So then, of course, this would be a compound we call butanol. And what your handout also said or illustrated is some of these chains can branch off. So what could possibly happen is if we take this here, okay, remember this was butane, which has a formula of C4H10, okay? So I'll cover this guy up here right now. There's your 4 carbons, 1 hydrogen above and below, so 4 times 2 is 8. Then you count your ends, that would be number 9, and then number 10. A straight chain of butane. But if we take one of those off, okay, notice we still have 4 carbons, okay? There's 3 of them in a row here and 1 down below this middle one. So there's your 4th carbon. And if we start counting these hydrogens, we've got 3 on this side, 3 on this side, so there's 6. Here's 7, and then 3 more gives you 10. So C4H10. So we have the same molecular formula, but the structure is different, okay? So one of the things that the author calls that is isobutane. But we will call that a different compound. We just want to illustrate what an isomer would actually look like. It means you have, again, the same molecular formula, but the structure is different. Okay. So I see we're up to 14 minutes. Let's go ahead and put some more examples up here. Okay. Let me try this marker once. Okay, so then notice we got 8 carbons in a row. So the prefix for, remember, once you get past number 4 and starting with number 5 is the geometrical shape. So if we have 8, we know an 8-sided figure is an octagon. Okay, so we're naming our parent chain, and if there's only hydrogens on here, if we put 1 above and below, 8 times 2 would give you 16, of course, and then you need to count the ends. We have 1 here, there's number 19, and then, oh, I'm sorry, 8 times 2 is 16, there's number 17, there's number 18, okay? So C8, H18, okay? So there's a pattern that arises from this. So we could jump up to 10 carbons, okay, just to show you that the math works out, okay? C10, and if we didn't know how many hydrogens would actually exist from there, we can use the same pattern that arises. It has a formula of this, CnH2n plus 2. And typically what happens is once you get a good understanding of this, you don't even need to utilize this formula anymore, because N is just this number right here, okay? So if we put, or let's maybe use this as an example to solve for it, because we did octane already. So if we put 10 in for N, that's all we're doing. This variable is N. So then how many hydrogens would that be? Well, we're going to use our math, our algebraic skills, we always say. If you have 10 here, okay, we put 10 in for N. You multiply 2 times 10, of course, gives you 20, and then you have to add 2 more to that. So then, therefore, we know that there's 22 hydrogens. Okay, so how can we illustrate that? Well, from prior knowledge, we just solved for octane here. We've got 8 in a row, okay? If we put number 9 and then number 10, okay? So we've got 10 carbons right in a row, okay? There's our C10, and it says that we're supposed to have 22 hydrogens. Well, if we count these out, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, okay? We put this 10 in for this variable. So 2 times 10 gives you 20, and it says count the ends, and that comes from this carbon or this hydrogen is on the end, then this hydrogen is on the end. So we're supposed to have 22. So again, just follow along. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and then count the ends. There's number 21. There's number 22, just like this says we're supposed to get. C10H22, then the last thing we would do is name this. Decane, because it's a 10-sided, because there's 10 years in a decade, that's a geometrical shape, so that's why we call that decane then. All right, let me go ahead and erase that. I probably should have left that methane up there. CH4, and think about it for a moment. What is that? Okay, so it's 2 carbons in length. It's saturated. It's an alkane. The prefix for 2 is ETH. So of course that is ethane. Okay. So what happens is, remember when you look at the periodic table, okay, if we had this element, okay, iron, and if you did not know where to look at on the periodic table, You might be scrolling through the different names and you see, oh, that must be iron because it starts with I. No. Of course, we know that's iodine. Okay. Oh, well, this is an element. It's got I and N. I mean, it starts with I and ends in N. That's got to be the symbol for iron. Of course, no. That's not the case either. That's indolium. Well, of course, if it has an I and an R in it, this must be the symbol for iron. And that's not the case either. That's iridium. So as you've been following along with this, you're probably telling yourself, we already know what the symbol for iron is. It's F and E. And of course, there is no F and E in this name. But I think what we have talked about in class is actually where this symbol comes from. Fe comes from the Latin term, which means this. If you have a ferrous metal, that means that you've got iron in it. Okay? So the reason we say that is since the symbol Fe is derived from this term. Here is your symbol for iron right there. So it means it's derived. It comes from this derivation of the terminology. Because when we say derivation, we can mean derivative then as well. Okay? And that's going to become more important as you start naming some of these organic compounds. We know that this is methane. Okay? And we know that this is ethane. Okay? Those are the hydrocarbons that we would actually utilize for this, and this comes from prior knowledge. But one of the things that we want to discuss today is what we call derivatives. Okay? So we have this molecule, which is called CH3 and C2H5. Now we know that this is one hydrogen short in both examples. Okay? And the reason for that is when we call these derivatives, this is called a methyl group. Notice I said group. We'll make more sense of that later. And 2 carbons in length is called an ethyl group. Okay? So these 2 names are derived from these alkanes, just like the symbol Fe is derived from the Latin term for ferrous. These structures and names are derived from their organic alkane counterparts. Okay? So what that means is, remember, we had this compound up in early part of our presentation. Okay? And what would this be called? Be asking yourself. Okay? You're probably saying, we already know that that is butane. Okay? And we know what is the formula for this butane. Well, C4H10. So that probably sounds familiar from what we had done earlier. But what we haven't done is the author calls this compound isobutane, which I really don't prefer that you go by that, what the author says. We want to know this as an isomer because remember, we did this earlier. It's got 4 carbons and it's got 10 hydrogens. We got 3, 6, 9 for your number of hydrogens. There's your 10th one. So we know that this is an isomer, C4H10. And in this case, this is the first isomer that we could actually discuss that has an alkane counterpart. The aspect that you want to do is always find your longest continuous chain. Okay? This is a straight chain, so it's pretty straightforward. 4 carbons, saturated, butane. The prefix is saying that there's 4 carbons. Okay, the longest continuous chain here, okay, is 3 then. You have 1, 2, and 3. So what is the prefix for an alkane that has 3 carbons in it. Okay, so now that you've thought about that, we know that it is this. Okay, PROP, that is your prefix. Then everything is single bonded in here, so it's also an alkane, so the same pattern arises. ANE, ANE, ANE. This also will end in ANE. So these patterns, they continually repeat themselves. I want you to think about what have we not accounted for. So we've talked about this, a 3-carbon straight chain here, but this is not straight like this because there's a branch on there. Okay? So what you would do then is, as you're looking at this, what is branching off of this middle carbon? Okay? And it is this structure here that has a specific formula, CH3. So where up here on the board do you see something that says CH3? So as you're looking at that, you'd probably say, of course, it's right here. Here we see CH3. Here's a carbon with 3 hydrogens. This has to be what we refer to as a methyl group. It's a derivative. This methyl name is derived or comes from the hydrocarbon methane. So the only thing that you're doing is accounting for what that methyl group is, okay? And where is that methyl group? You just do a process of numbering, okay? It's right here in the middle on the 2nd carbon. So there's where it is, number 2, and you would just put methyl in front of there, okay? And one of the things that we talk about as juniors and as seniors as well, you can reverse engineer this by looking at the name, okay? So what we talk about or do is this tells you your organic family. We know that it's an alkane, okay? Everything in there is single bonded, okay? This tells you how many carbons are in your parent chain. PROP means there's 3. Well, there they are, okay? This is saying there's a methyl group. And a methyl group we know has a formula of CH3. There's a CH3 group right there. Where is that methyl group located? This tells you where it's at. It's on the 2nd carbon. In other words, here's number 1, here's number 2, and here's number 3. So 3 carbons in a row, your parent chain. It's single bonded. It's an alkane. This says there's a methyl group, or CH3, and that tells you where it's at on the 2nd one. Okay, I just want to do one more example. I'm just going to hit pause for just a moment. Okay, so it's changed just a little bit on here. Okay, I don't know if you can see the distinct colors. I don't think so, but this is that gold or rustic color, and then this is a purple color. Okay, so the first thing I want you to do, okay, is this is what it would look like. The first thing I want you to do is find your longest continuous chain. Count the number of carbons. Okay, so go ahead and do that now. Okay, so now that you've done it, I think when I did that, I think it was 7. So 1, 2, 3, 4, 5, 6, 7. Okay, so it's a 7-carbon compound. So what is the prefix for an alkane with 7 carbons? If you wrote this down yesterday, this is where you could utilize that. And if you have this as HEPT, that would be correct. That is the prefix for a 7-carbon compound. It's all single bonded, so it's an alkane. Okay, and then is there anything branching off of that? And of course the answer to that is yes, and we see a structure with the formula of CH3. And ask yourself, what does CH3 mean? It is not methane, because methane has CH4. But we do see this as CH3 means there's a methyl group on here. And when we get further on into these examples, and the seniors do this too, they still follow this same process. They will actually put numbers inside of here, okay? So as they're counting, they know that, okay, there's 7 carbons in that parent chain, okay? Here they are. There's your prefix. It's saturated. It's an alkane, so there's our suffix or our organic family. And then is there anything branching off of this? Yes, there is. It's a structure with a formula of CH3. That means there's a methyl group. And on what carbon is that methyl group located on? Okay, that's where this numbering helps you. Okay, so what we see then is on number 3, okay, we have a what group? Okay, well, CH3 means there's a methyl group. Okay, so we've got 3 methyl heptane. Okay, you may have a lot of questions up to this point. I think that's a good place to stop. Okay, so again, if you are having problems with this, yes, you could probably ask some juniors, they might remember this, but your best resources for students, we go to find one of the seniors that has been taking this organic and biochemistry class, and all it takes, just say, could you please help me with this? Just remember, just say please, and they will probably help you. Okay, so that's all I have. We will continue with this on Tuesday. Again, for you individuals that are in track, okay, it's easy to fall behind on this because no one's going to say that this is easy material to do. It's not. So please don't fall behind on that. Enjoy your Easter weekend, and we will catch up to you next time.